Domain and Range, Chapter 11.2. First, recall that we're talking about functions, and with functions you have an input, and every input goes to one output value, and it's a consistent process. And we have function notation, which is f of x, and you can think about that as your y, or your output value, where x is your input value. Domain is the collection of input values, anything that is possible for the input. The range is the output, anything that can come out of our function. In this first example, we're going to use context to determine valid inputs. It costs $25 to rent a tent and $10 each night you use it. A formula can be used to find the total cost, C of n, for each night, n, you use the tent. And they give us the function, C of n equals 25 plus 10 times n. Find and interpret C of 3. So they give us a note that interpret means to write the answer in everyday English. Probably want to know what C of E represents in terms of camping and money. So the first thing we'll do, and I often forget this, is to write the function that we're working with. And let's go ahead and solve for C of 3. And we'll see that the 3 is in the n position. Probably should remember my n in the equation, and we will substitute 3n for n. And then we will have C of 3 equals 25 plus 30, and we will have C of 3 equals 55. And so that's the answer, but it's not in everyday English. The 3 was the n, and the n was each night, so we camped for 3 nights, and it cost us $55. So I'll write that out. Find and interpret C of negative 2. Remembering to write the equation and the variable this time. C of negative 2 equals 5. And if we were to interpret this, it's going to be a little bit more difficult. What does it mean to camp for negative 2 nights? That's what it's saying. To camp for negative 2 nights. Maybe this would be my sister and how she would camp. She doesn't really like camping. Would cost $5. All right, so this doesn't make any sense. When you go camping, you don't camp in reverse, and the minimum cost was $25. So what we're finding here is that negative 2 is not an input, and 5 is not an output. So I'm going to write in parentheses, makes no sense. So what we're going to do now is describe the set of numbers that are valid inputs for the function based on the context. And we are going to write this work in a table, for example 4, which is another page on. Valid means that you're going to get answers for the output that makes sense, and the input also makes sense. So the set of numbers that are valid inputs. Let's think. What would be a good input? I could camp for 1 night. That makes some sort of sense. 2 nights, 3 nights, and so forth. Okay. Could I camp for 0 nights? I suppose maybe I rented the tent and like turned around and didn't, maybe my car broke down and they still charged me the $25. You could argue that maybe 0 doesn't belong, or it does. That's up to you. So I'm going to say positive whole numbers are valid inputs. And the reason I've decided whole numbers are valid inputs is I typically think about camping in whole number of nights. I don't camp for 1.5 nights. And again, maybe you could maybe go camping and then decide that this is just not working out and leave at midnight. But as far as this company goes, they're probably only going to put in whole numbers and the way that they charge you. And certainly I would plan for a whole number of nights. So let's take this work that we just did and we're going to put it in this chart for example 4. See from example 1, and my verbal description was positive whole numbers. Okay, and I think that I just spelled positive in 2 different ways. And then what we're going to do with this is we're going to graph it on a number line. We're going to talk about these other new concepts called set builder notation and interval notation. And that'll be coming up here in a second. But let me also correct my spelling for positive. Okay, I should know how to spell my math words though. Finding the domain. All right, when you're finding the domain, you're going to start by assuming that the domain can be really any number. And so the any number idea is the idea that it could be all real numbers. Real numbers are fractions, decimals, negatives, any number that you've been more used to working with, even some weird numbers like pi and e, they're all real. Imaginary numbers we probably won't get into for a while. They are not real. So you start with the idea that you can go from negative infinity to infinity. Then there's a few things that don't really work very well in math, and the first one is that you cannot divide by 0. So if your function has a division symbol, and if you look below that one does, you have to think about what x values could cause a 0 to occur in the denominator, because that is not allowed. Then you want to look for square roots. You can't take the square root of a negative number and get a real number, because the square root of, let's say, -4, we talked about a little bit earlier, doesn't really have a nice answer, because -2 times -2 is a +4, and +2 times +2 is also a +4. It's very hard to get a negative. And that's where imaginary numbers come in. But again, we're not going to get into that. This first one, we started with the idea it could be anything, but then this one has a division symbol. So we're going to think about what could cause a 0 to occur in the denominator. So I'm going to write that down. What could cause the denominator to equal 0? And I'm going to solve it. Now, I have that x could equal 5, because the square root of 25 is 5. And x could equal -5. So those are the 2 x's that are not allowed to be my solutions in this function. So x cannot equal -5 or 5, but it can be anything else. What we're going to do is describe the domain for its function and then write that description in that table from before. So x can be any number, I'll say any real number, except -5 and 5. All right, so take that description and we'll put it in that chart from before. All real numbers, but x cannot equal 5 or -5. All right, and last one, number 3. We have a square root symbol. Find and interpret an input that would cause an undefined output. So they just wanted one input. All right, so what input would cause a problem? And the problems occur in square roots when you end up with a negative. Let x equal, what if we let it equal 5? If x equaled 5, we would have h of -5 would equal the square root of 3 minus 5. H of negative 5 equals the square root of negative 2. Yuck. All right, so this is undefined. So when would that undefined point start is what you want to think about. What's the first square root value that you're allowed? So you know you can take square roots of positives. That's fine. You know you can't take square roots of negatives. So that division between positives and negatives is 0. So similar to what we were doing with the denominator, we're going to set the work that's under the square root symbol equal to 0 and solve for what x values we're thinking about as being the breaking point between what works and what doesn't work. So that's 3. And can you take the square root of 0? All right, is there a number times itself that makes 0? Yep, 0. So that 3 is allowed. 3 is a part of our domain, but 5 was not a part of our domain. And so that gives us an idea that all numbers, all real numbers, less than or equal to 3 will be a part of our domain. They will work. We can get answers for them. Maybe not answers you like, but nonetheless. All real numbers less than or equal to 3. Great. Now, mathematicians don't really like writing in sentences. Maybe it's because we can't spell things like positive. I don't know. But we tend to write in some interesting ways. We have some notation, set builder notation and interval notation that we're going to go through. And the cool thing about these is you could be doing math in a different country and using a different language, and people would still understand what you're saying, because math is one of those universal languages. An earlier visual representation of what might be going on, you probably have had some exposure to, is the idea of graphing something on a number line. And so what you would do here is you would just get the pattern started. So 0, 1, 2, 3, and so forth. And we are saying that positive whole numbers existed. And so what we're going to do is we're going to make a number line for each of these domains. The next one was all real numbers, but x could not equal 5 or negative 5. So for this number line, I'm going to make an open circle at negative 5. It implies that my x's cannot be in those spots. And I'm going to fill in this number line. I'm going to make it a little bit thicker. And then all real numbers less than or equal to 3. And I'm going to give you 2 number lines. I'm going to give you the one that I do more often and the one that your book does. I put a 3 down, and it's allowed to equal 3, so I fill in the circle, and it's any numbers less than 3 worked, so I make this side a little bit thicker. Now your book will do this instead. At the 3, if it equals 3, they will do an inclusive bracket, and I will talk more about those here in a second. And we'll thicken the line to one side, and those have the same meaning. I would accept either. And then here's this new stuff that we're going to talk about. It is going to be set notation and interval notation. Whoa, okay. In set notation, what we'll do is we'll start our work with a set bracket, and that is saying the set. And then we talk about who are these? These are x values. And we will say such that line is such that. Well, you know what? I think it was not x. It was n's for the number of nights. The set of nights such that n is greater than or equal to 0. I'm allowing 0 to be a number of nights that you can go camping. and then you just describe the interval of nights. Now, your book really doesn't go over this very much, but I'm going to add it in for those of you who care. I had said that I only wanted positive whole numbers, and so you can add in a little bit of extra notation to allow n to be positive whole numbers. What you'd say here is n is an element of, and the symbol for whole numbers looks like a W with an extra line in it. The set of whole numbers. And then what that would do, it would allow for the fractions to not be a part of our answer. And then we would still say that n is greater than or equal to 0 on the other side. So for now, this top one's fine. We don't have to add any more symbols. And then interval notation. Interval notation uses bracket and parentheses. So that's the idea of the closed circle or the open circle. Do you get to equal it, or do you get really, really close to it? What we're going to describe here is the interval. So we'll say including, you start with your lowest number, including 0, and we're going to allow this to go infinity, the largest number that one could go to. So they didn't give us an end to our camping, even though maybe it makes no real practical sense to camp forever. I certainly wouldn't mind. Okay. Set builder notation for this one, we had x's, so the set of x's such that, and that's allowing x to be anything, so we'll say x cannot equal 5, we'll just use a comma, or -5. Interval notation, we can describe the 3 intervals on the number line. So we'll go from -infinity, and the reason this gets an open bracket is because you don't get to equal infinity, you can't really be at infinity. Then 2, 5, you weren't allowed to put 5 in, and then we had from 5 to -5, and then we had our last interval 5 to infinity. This last one down here, we have the set of x's such that x is smaller than or equal to 3. With this one, we would start with our smallest number, which is -infinity, because it could go on forever in the negative direction, and it stops at 3, and it can include 3. Had that been an open circle, we would have used the rounded parenthesis like we did above. What you're going to do is try this yourself. I've given you functions for you to think about, and I want you to try to write in set builder and interval notation. There's also some more examples in your book if I didn't give you enough. All right, that's where we're going to stop this first part of the video, and I'm going to introduce another symbol called the union symbol next.